Now let's try to see the relationship between symmetric and irreflexive relations. Symmetric and irreflexive, not reflexive. We have already seen between symmetric and reflexive. Now we are seeing the relation between symmetric and irreflexive. Okay, see this. So first of all, whenever you try to derive the cardinality of various areas or regions present, you should be able to draw the figure, exactly, in the sense, is this figure right? Which means if I write that this is set of all symmetric relations possible on a set A, and one more thing, we are talking about the number of relations here possible on a set A with cardinality n. This is the basic assumption. Now I am talking about the relations which are possible on the set A, which means A cross A. Now out of all these relations, I want to know how does the set of all symmetric relations behave and the set of all irreflexive relations behave. So I don't know whether this is true or false, but then I'm just doing it, and now I'll try to give some examples to justify that this diagram is right. In case if there is any counter example saying that this diagram is not right, then I'll change it. Okay, so I don't know whether these are disjoint or having some intersection part. I don't know that yet. I have to test it. How can I test it? If there is at least one relation possible here, then I can say that yes, there will be some relations which are not either S or I. If there is at least one relation that I can find here, then I can say that there will be some relations, there is at least one relation, which means there is a presence of this area in such a way that there is a relation which is symmetric but not irreflexive. If I can find a relation here, which means a relation which is both symmetric and irreflexive, then I can say that yes, this area is justified. Likewise, I want to give at least one example to justify the existence of each area. Right, and if you are not able to find anything here, then I can say that both are disjoint. In case of later we can get the disjoint examples. I think till now we didn't get any such sets. There is intersection between symmetric and there is no intersection between reflexive and irreflexive, I guess, isn't it? So if you see reflexive and irreflexive, we got sets like this: reflexive and irreflexive. This is the total set of relations. What does it mean? There is no relation which is both reflexive and irreflexive. That is why they were disjoint, and so this diagram is justified, right? And now I want to see if this is justifiable, right? And why am I doing this? Because there are some questions possible which will be like this. We know the number of symmetric relations possible, already we have seen it, and we know the number of irreflexive relations possible. Now the questions might be, what is the total number of relations which are either symmetric or irreflexive? In that case, they are asking about S union I, right? Now if the diagram is like this, then S union I will be, N of S union I will be N of S plus N of I minus N of S intersection I, because there is intersection part, right? But in this case you need not subtract it. So that is why it is very important to know this diagram. And sometimes they will ask how many relations are possible which are symmetric but not irreflexive. Then they are talking about this region S minus I, this region 1. Let's number the regions. They are talking about region 1, right? In this example, if they ask about the number of relations which are reflexive but not irreflexive, then it is nothing but the number of relations which are reflexive itself. But here we have to subtract some relations from symmetric. If they are asking about number of relations which are symmetric but not irreflexive, then we have to subtract here. Getting this? Okay, so now let's get down to the point of justifying them first. So can you find any relation which is symmetric but not irreflexive? Which means, will there be this region 1 at all? That is what I wanted. So just for that region, let's say I'll give you one example. R1 equal to, I am forming the relations which are symmetric but not irreflexive. 1 comma 1, that's it. This is symmetric because xy is present and yx is present, which is of course itself. And now this is not irreflexive because x comma x is present. isn't it? Therefore, what can you say about this relation? This R1 is symmetric but not irreflexive, isn't it? R1 is symmetric but not irreflexive. Now I want to find out whether this region 2 is justifiable. If it is existing, if there is at least one relation existing, which means I want to find out some relations which are symmetric and irreflexive. Let us say 1 comma 2 and 2 comma 1. Now this is symmetric, isn't it? As well as this is irreflexive. Why is it symmetric? xy is present and yx is also present. That is why it is symmetric, and it is irreflexive. Why is it irreflexive? Because there is no x comma x elements present here. Therefore, yes, region 2 can be justified with R2. What about region 3? Let me give you an example for region 3. There might be some relation which is present in region 3. So what is region 3? The relation should be irreflexive but not symmetric. So you can take simply this one. This is an example of a relation which is irreflexive. Why is it irreflexive? Because there is no presence of the element x comma x, and it is not symmetric. Why? Because xy is present and yx is not present. Right. Now what about region 4? Will there be any elements? Will there be any relations which are not symmetric and irreflexive? Now if I write 1 comma 2, 1 comma 1, now because of this element it is not irreflexive, and because of this element 1 comma 2 and the absence of the element 2 comma 1, it is not symmetric. Therefore R4 is also justifiable. So whatever diagram we assumed is right. So how did I directly draw it? I didn't know that. I was just trying out, and I am successful in the first hit. It is just a hit and try method. If this one fails, then you might have to try with this. Got it? So if you don't find any example, let us say in R2, then maybe this will be true, isn't it? You have to search like that. If you are not able to find any example in region 3, then what does it mean? There is no relation which is irreflexive but not symmetric. Then what does it mean? The entire I must be present inside S, isn't it? So if there is no region 1, then what does it mean? The entire S might be present inside I, right? So likewise, if you are not able to find an example, then you try to order them around. Okay, now in order to answer various questions, so we have to know only the region 2. We know already region 1. I mean to say n of s. So let's write them. What is n of s? The number of symmetric relations which are possible on A. We have already seen it. So what is it? 2 power. So in order to get the symmetric relations, all the diagonal elements are going to give us 2 power n cases, and the remaining n square minus n we have to actually put them in pairs. So I have already derived that, so I am directly writing it n into n plus 1 by 2, I guess, right? So we get actually 2 power n plus n into n minus 1 by 2. So if you add it, you are going to get n into n plus 1 by 2. So this is the cardinality of the set, yes, which means the total number of relations which are symmetric is this one. And we already have seen what is the cardinality of n of I. The number of relations which are irreflexive on a set, yes. If the set has to be reflexive, you have to completely remove the diagonal elements, and from the remaining elements you can pick them, any of them, right? Therefore 2 power n into n minus 1, isn't it? So this is about n of s and n of I. Now I want to find out n of s intersection I. So what is it? Number of relations which are both symmetric as well as irreflexive. I want to find out the intersection. Number of relations which are both symmetric as well as irreflexive. Now how can we find them? So if a relation has to be symmetric and irreflexive, first of all we have to delete all the diagonal elements, which means if A cross A is going to contain 1 comma 1, 2 comma 2, so on, n comma n, all the diagonal elements, and then 1 comma 2, 2 comma 1, the non-diagonal elements. Now if I have to form relations which are both irreflexive and symmetric, first of all you should not include any of these elements, because presence of any of these elements is going to cause the relation to be it will not become irreflexive. That is why I have to delete them. And now in the remaining elements you can choose any of them and you can make irreflexive relations, but to make the symmetric relations you have to again pair them, x comma y comma x pairs. How many elements will be remaining here? Totally n square minus n elements will be remaining. Now you make them into pairs, then this is the total number of pairs, then each pair can be included or it may not be included. Therefore we are going to get 2 power n square minus n by 2. This is the total number of relations which are both symmetric and irreflexive. I hope you are getting it, right? If you didn't get it, let's say a equal to 1 comma 2 small set, then what about a cross a? A cross a will contain 1 comma 1, 2 comma 2, 1 comma 2, 2 comma 1, isn't it? Now this complete part has to be eliminated, and in the remaining part you make them into a pair. Now either include this entire pair or not. So how many you get? 2 power 1. So 2 power 1 relations we get which are both irreflexive and symmetric, right? In case if you have more non-diagonal elements, then we are going to get more pairs. That is why here I got 2 power n square minus n by 2. So this is the part of it. The cardinality of S intersection I is 2 power n square minus n by 2. I think this is same thing, right? The same answer we got even for symmetric and reflexive. Here I am getting the same one for symmetric and irreflexive. Got it? Okay. Now there can be various kinds of questions. One kind of question is, what is the total number of relations which are both symmetric and irreflexive, which means they are asking about this S union I, which are either symmetric or irreflexive. Sorry. So what is it? The number of relations which are either symmetric or irreflexive, which means they are asking about S union I. So S union I equal to n of s plus n of I. Okay, so when I write n of s plus n of I, it is nothing but 1 2 plus 2 3, which means 2 is added 2 times. Why? Because it is added once while counting s and it is added once while counting I. Therefore you subtract it, minus s of n of s intersection I. So you can just put those numbers. You can just put those numbers and you can do that. Now one other kind of question is, what is the number of relations which are symmetric but not irreflexive, which means they are talking about the region 1. So how can you find out region 1? N of s minus n of s intersection I, isn't it? So if you want the region 1, you take region s, which means 1 and 2, and from that you subtract 2. That is why we got n of s. S of s means 1 comma 2. If you are not understanding it, you can write this in numbers of these areas and you will understand it. See, n of s is 1 comma 2 minus n of s intersection I is 2. So if you subtract it, you are going to get 1. Got it? So, and other kind of questions. Okay, just directly substitute these values. We have already found out the values. What is n of s intersection I? We already computed these values, right? So you have to just substitute them. Now if you are trying to do n of, let us say, number of relations which are irreflexive but not symmetric, then how can we find out? It is n of I minus n of, see this, they are asking about region 3. So how can we find out? N of I, which means 2 comma 3, minus, we have to remove 2. So what is 2? N of I intersection s, right? So you are going to get 3. Now they might ask you, what are the relations which are neither symmetric nor irreflexive, which means they are talking about region 4, right? So they are trying to ask n of I union s complement. So what does it mean? Neither irreflexive nor symmetric. So how can you find out? How can you find out region 4? Region 4 is nothing but total relations. So total relations let us call n of u, which is nothing but 2 power n square, isn't it? The total number of relations possible on a set using n elements is 2 power n square. We know that already. So n of u minus n of I union s. So we have already found out this I union s. So these questions are possible. So whenever they are asking about a combination of two types of relations, you always try to draw the diagram first and try to see what areas are possible. Once you can find out what areas are possible, it will be really easy to find out to answer these questions. Sometimes you may not be able to answer the questions directly. If you try to derive the number of symmetric relations which are not irreflexive, it might be difficult. So instead of that, if they are asking for area number 1, directly jumping into it and trying to solve this as a standalone question is difficult. If you can see the relationship and if you can find out the region 2 first, then finding out region 1 and region 3 will be easy. Then finding out region 4 will be easy. Got it? So how do you know which one to find out? It is just intuition. So if you solve more and more examples, or at least if you go through all the videos, you will develop that intuition. Don't worry about it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.